This is a modified version of the original Atari game Space Invaders. Using 7 LiDAR arrays and the score as its only inputs, this game is being played by a brain-inspired computer which has utilized a genetic algorithm to build a spiking neural network that is optimized to get the best score. Welcome to the University of Tennessee's Neuromorphic Computing Lab. We are researchers exploring all facets of neuromorphic computing, from devices and hardware to software and algorithms. A lot can be learned about neuromorphic technology through the lens of our Space Invaders application. So what is a neuromorphic computer? Well, the word neuromorphic breaks down to literally mean brain-shaped. This technology takes inspiration from the brain in a number of ways. The brain functions while consuming about 20 watts of energy. This means that its computation is very energy efficient and requires extremely low power. The brain is massively parallel, which means it's able to complete many computations at the same time. The brain takes information from a given state and makes its computations based on that event's data. The brain takes care of memory storage and energy supply without the use of an external battery pack or storage unit. Neuromorphic computing harnesses these characteristics by modeling after the brain's building blocks, neurons and their synapses. Synapses are how neurons communicate with one another in the brain. When a neuron acquires a certain amount of charge, it may reach the threshold to produce an action potential. We refer to this action potential as a spike. These spikes release charge to other neurons, which also may spike if their threshold is met. This chain reaction is essentially how neurons communicate. With a spiking model, we're able to perform neural network tasks with much less energy than other models, because when the synapses are not firing, they're sitting idle and therefore not consuming any power. Our goal with Space Invaders is to have a brain-inspired controller that is a spiking neural network playing the game. In Space Invaders, the network is made of inputs that represent the laser LiDARs and outputs that represent the moves that can be made. At periodic intervals, decisions are made by this network as to what it should output based on the inputs that are the state-driven data. Because a point can only be earned if a Space Invader was successfully hit, the score can be used as a measure of if the network has successfully mapped a LiDAR to a relevant output. During a training session, given a starting seed, a random network is generated which attempts to play the game. The score of this network is used to optimize a genetic algorithm, which produces even better scoring networks. Over time, the networks being built have learned which LiDARs signify a need to move or shoot. Watching the brain-inspired controller playing Space Invaders, you may notice that this particular network has learned to shoot one cycle after the LiDAR to the right of the middle has been detected. The promising results of this application and others that utilize this brain-inspired controller are telling that the use of networks structured closely after neurons and synapses, and the use of an evolutionary model to make new networks should continue to be researched and developed. With the imminent end of Moore's Law, we hope that research in neuromorphic computing will get us closer to the goal of improving and reinventing modern microprocessors to be smaller and require less energy. Thank you for watching and learning about neuromorphic computing. This research is the combined effort of students and faculty at the University of Tennessee's TENNLab. Please check out our website for more information about our developing research.